All right, guys, so I want to spend a little bit of time on data types. So when you're dealing with code, any type of code, any language, and you're dealing with data, that data is associated with some kind of data type, okay? And it doesn't matter which language you're using, they all have some kind of data types, and they can be different language by language. Now in JavaScript, you essentially have two types of types. You have primitive data types and you have reference types or objects, and I'll talk about those in a second. But I want to start off with primitive data types. Now, I feel like a lot of JavaScript courses kind of skip over some important fundamentals, and what I want to do is, I'll talk more about this in the next video, but I want you to understand how these data types are stored and how primitive data types are different or accessed differently than reference types. But again, I'll talk more about that in the next video. Right now, I just want you to know what these types are. So the first is a string, which we've dealt with. So a string is essentially a sequence of characters, and a string must be enclosed in either double quotes or single quotes or backticks. Next, we have a number, which are integers, which could be positive or negative numbers, as well as floating point numbers or decimals. Now, in some languages, you actually have either a decimal and or a float type. In JavaScript, we don't. Whether if it's an integer or if it's a decimal or a floating point number, they're all the same. They're all going to be the type of number. Okay, so keep that in mind. Next, we have a Boolean, which represents a logical entity. It can be either true or false. Next, we have null, which is the intentional absence of any object value. And a lot of people get null confused with undefined, which I'll talk about next. But just know that null it's intentional. It's supposed to be there, but it's supposed to be null. It's supposed to be empty. You can essentially think of it as empty. Now, the next one, undefined, is a variable that hasn't been defined or assigned. Okay, so null is purposeful, undefined usually isn't. All right, next we have a symbol, which I'm not going to talk too much about right now because it's kind of advanced, and it was actually added in ES 2015 or ES 6. So a symbol is essentially a built-in object whose constructor returns a unique symbol, or a symbol that is unique. All right, and we'll get into that later. It's not something you use very often, at least I don't. And then the last one is a new data type that was just recently added called big int. Okay, and it just represents really, really big integers, really large numbers that the number type can't handle. All right, and we will jump into some code in this video and just kind of show you how to store each of these in a variable. So the next type is reference or objects. Now, reference or objects, they're non-primitive. And when we assign a reference type to a variable, the variable is given a reference to that value. And again, I'm going to talk more about how reference types and primitive types are stored and accessed in the next video. But object literals, arrays, functions, these are all examples of reference types. Now, in programming, you have something called static typing or statically typed, and you have dynamically typed. JavaScript is a dynamically typed language, and what this means is that we don't explicitly define the types for our variables. So if I say like const name equals Brad, I don't have to put const name string equals Brad. It just knows it's dynamic. With many languages, you actually have to add the types yourself. Those are statically typed languages like C, C++, Java, and I'm sure that some of you have worked with some of those languages. In JavaScript, you don't explicitly set your types. However, there is something called TypeScript, which is very, very popular, and it's a superset of JavaScript, meaning that it's everything that JavaScript is. It essentially is JavaScript, but it also has some additional features, including static typing. Okay, so there are reasons to use static typing. It is more code that you have to type, but it can make your code more verbose and it can make it less prone to errors, and a lot of people really love TypeScript. So that might be something you want to look into once you really learn the fundamentals of JavaScript. Okay, so I just want to jump into VS Code and go over these types in the text editor and also show you how we can get the types of a specific variable. So let's start off with strings, which are very simple. They're just sequences of characters. So I'll create a variable, and I'm using const. Like I said in the last video, I use const for everything unless I know I'm going to reassign it. So we'll say first name, and we'll set that to Sarah. All right, now I want to console log out the value, so we'll say first name. But I also want to show you how we can get the actual type from this first name variable. So as a second argument, I'm going to pass in the type of operator. Okay, so just type of and then a space and then whatever you want to get the type of. So first name. And now you'll see it's logging out Sarah and string. All right. Now there's going to be a few variables that I want to show the value and the type, and I don't want to type it twice. So I'm going to create another variable here. We'll just call it output, and for now I'll set it to first name, and then let's come down here and put output. Now I just want to mention some little tips and tricks as we go along. I already went over some shortcuts, but just to kind of remind you, we can go to the end of this first name, hold shift and then highlight it, and then we can do a command or control D to select the next instance of first name and then replace it with output and then save. Okay, and we should get the same result. So I'll just mention little tips and tricks like that as we go along. So the next type I want to look at is number. So let's do const. We'll say age equals 30. So that's an example of a number. If I change that to age, we get 30, and it shows number from our type of operator. Now I also want to mention that decimals. So if I do temp and set that to, let's say, 98.9, and then we look at the type for that, that's also going to be a number. There's no specific float or decimal or anything like that. Everything is a number in JavaScript. So the next type is Boolean, which is really simple. It's just a true false value. So maybe we want to say like has kids, since we're talking about a person, and we'll set that to true. And then we'll come down here, we'll change the output to has kids, and we get true, and it says Boolean. So the next one is null, which is basically like an intentional empty value. So maybe we have like an apartment number, but let's say this person lives in a house, so we set that to null. There's no apartment number. There's no need for one. And this one is a little weird, because if we set this to apartment number and we look at the value, which is null, and then we look at the result of this type of, we get object. Okay, now this is a little confusing because null is not an object, it's not a reference type, it's a primitive. But there's a reason for this. It's kind of, in summary, it's kind of a mistake. In fact, I'm going to paste in the link right here if you're interested, and we can check it out real quick. So let's go to that link, and it just kind of explains why this happens. And it has to do with the first implementation of JavaScript. Values were represented as a type, tag, and value. The type tag for object was 0. Null was represented as the null pointer, which was 0x00. Consequently, null had 0 as a type tag, hence the type of return of object. So in case you're wondering why it says object and not null, that's why, but it's not that important, honestly. Now the next is undefined, and you're probably not going to purposely set variables to undefined very much, but just to show you, if we were to do, remember in the last video I showed you we can use let to just create a variable but not actually define it to something. So I'll just say let score, and then we'll pass that in here to output so we can see the value and the type, and both are undefined, the value and the type. Okay, so if you just set a variable and you don't define it, it's going to be undefined. Now you can also explicitly set it to undefined. You don't do this very much, but I could say const score, let's just comment this out, and I could just say set it to undefined, and we get the same thing. All right, now a symbol is a primitive type, but it's not something that you're probably going to use very much, especially in your early career. But just to show you, we can create, let's say, ID, and let's set that to symbol. So we're going to say symbol with parentheses, and then pass in a unique identifier of ID. And then we'll change this to ID and save, and you'll see we get symbol as our type. And then the last one is, or I should say the last primitive type is big int, which is just a really big number that is too big for the number type. So I'll say const n, and I'm actually going to just copy or paste in this number here. So it's basically this long string of numbers and then n. And if we were to put n right here and save, we get the type of big int. Now, as far as reference types, let's come down here. And in the next video, I'm going to talk about the difference in how primitive and reference types are stored and accessed. But as far as what reference types are arrays, object literals, functions. So just to give you an example, we'll create a simple array. I'll call it numbers. Okay, and then if I were to, actually we want to put, let's grab this and let's put this up here. We want this above the output. And then let's change this to numbers. Okay, if I save that, it's going to show the array as the value and object as the type. Okay, any reference type is an object. So an object literal, of course, is also an object, is also a reference type. So if I say person, and we're going to learn all about objects and arrays and get much more advanced, but just to show you, we'll say Brad, and then if we change this here to person, you'll see we also get object. Now a function is also a reference type. So I'm just going to create a very simple function called say hello and just have it do a console log of hello. And then down here, let's swap this out for say hello. So you'll see for the value, for the console log of the value, it's just the function itself. I didn't call it with parentheses. And notice that instead of object, it says function. Now, it's still an object. It's just defined as a function object. And I'm going to put the documentation link here if you want to read more about that. And in the final version of the sandbox, I'll label what these links are and stuff. So I'll make things a little neater. But yeah, that's it as far as what the types are, the primitive types and reference types or objects. In the next video, I just want to quickly go over how those are stored in memory. All right, guys, so in this video, we're going to look at how primitive and reference type data is stored in memory. And one thing I want to mention is if you're a beginner and some of this is kind of confusing, that's okay. This is kind of like behind the scenes stuff. And the reason I'm putting it in the course at this point is just to give you a bigger picture of not only the syntax to write for your JavaScript code, but to also understand how JavaScript works. So if you don't completely soak in this video, that's absolutely fine. You can always come back to it later, and we'll talk more about this stuff later as well. So when we store our data, when we set a variable, if it's a primitive type, it's stored in an area in memory called the stack. Okay, if we store a reference type, such as an array, an object, a function, that's stored in an area of memory called the heap. Okay, so you have the stack, which is where your primitive data is stored, and you have the heap where your reference types are stored. So just keep that in mind. All right, now to kind of visualize how we store and access data, I created this diagram with kind of multiple scenes. So first off, let's say we create a couple variables. We have a name that's equal to John, which is a string, which is a primitive type, and then age equals 30, which is a number, which is also a primitive type. Now this box over here represents the stack in memory. So you can see age, the name of the variable, and 30, the value, are stored on the stack. Same thing with name and John. Now, if we were to create a variable called person and set that to an object, which is a reference type, you can see the variable is stored on the stack, but it accesses the data by reference, and that data is stored in the heap. All right. Now, just to kind of show you more about how this works, if we create another variable called new name and we set it to name, okay, up here, which is John, Then on the stack, we have a new variable called new name, and we have a new piece of data called John. Name is still equal to John, and now new name is equal to John. Let's say that we want to take that new name variable and reassign it. Remember, when we use let, we can reassign. So now we have new name equals Jonathan. So it overwrote the old value of John to Jonathan. Now let's kind of do the same thing and say, well, we're going to create a new person variable and set it to person, which is this object right here, Brad, name Brad, age 40, 41 now, but that's fine. So new person is put on the stack, the variable, and it points to the same reference that person does. Okay, so it doesn't create a whole new value like up here where we created John again. It just points to that area in the memory heap. So if we were to, let's come down here and let's say new person dot name, which is a property, this property right here, set that to Bradley. Now what's going to happen is we're changing in the heap that name value of Brad to Bradley. So new person dot name is going to be Bradley, but so is person dot name. In fact, right here, if we logged person dot name, it's going to be Bradley. Even though we changed new person dot name, the reason for that is because they both point to the same reference. All right, so that's kind of what I want to get across here is with primitive types, the value is stored on the stack. So even if you change new name to something, name is going to stay John because John is there. It's solid on the stack. With objects and arrays and so on, you have a reference. So if you set a variable to another variable and change something in that, it changes the reference. So what I want to do now is jump into VS Code and show you this exact thing in the text editor. So I have this empty script.js, and we're going to do the same thing. Let's say const name equals, we'll set that to John. And then we're going to set the age equal to 30. So these are both primitive values. In fact, I'll put a comment here, and let's say these values are stored on the stack. All right. Now, let's say reference values are stored on the heap. So let's say const, and we'll say person equals, and let's set that to, let's say name. And we're going to have an entire section on object literals like this, so don't worry if you don't fully understand the syntax. So we'll say age 40. All right, so we have our primitive values and we have our reference values. So I'm going to do what we did in the slide, and let's say new name, and I'm using let here because I'm going to reassign it. So I'll say new name, set that to name, and let's just do a console log down here of both name and new name. So now we get John and John for both the name and new name. And don't worry about this being crossed out. It's just because name is a deprecated property on the window object. It has nothing to do with what we're doing. So now let's go ahead and reassign. We'll say new name, and we'll set that now to Jonathan. So if I save that, now we get John and Jonathan. Now let's try the same thing with the reference type. So I'll say let new person, set that to person, and then down here let's console log person and new person, and we get both, they're both the same, right? Name Brad, age 40. So now what I'm going to do is take new person, which I got the value from person, but remember these are stored in the heap and they're accessed by reference. So if I were to change the new person name to Bradley and I save that, notice both person and new person both are now Bradley. Okay, because these are both stored in the same spot in the heap, and they're being accessed by reference. And that diagram should really help you understand why it's doing this, right? You can see they're both pointing to the same spot, but with the primitive values, the values are stored right on the stack. All right, so I hope that this made sense. In the next video, we're going to look at type conversion because sometimes your types can change. whether it's implicitly or explicitly. So we're going to talk about that next.